Hello everybody and welcome back. Today we're looking at exponents once again. We are continuing with the page handout that I gave you. So we're going to look now at question number 2.1 where we have the question, and I'm going to ask the most intelligent grade 9A class to help me with this, please. Alright, so I'm going to, because I can't do this on my own. I need their assistance. So question number 2.1, what is the question there? It reads as 2a, 3a, 2a, b. All right. So what? ABC. Okay. So what does the dot mean? Times. It means multiplication. All right. So that means now before in previous years we had 3 times 2 times 3, and you're supposed to be on a grade 9 level. So you're supposed to know what is that. All right. The answer there. 18. All right. 18. And then we have a is to the power of 1. A to the another power of 1 there. A to the power of. Alright, now listen. Just want to recap here. Guys, girls. We need some silence now. Because otherwise I won't be able to use the video. So you don't have to include the step. But because we're doing, like we said, the dots is multiplication. And our basis of A is the same. And it's repeating. So therefore we can say it's A plus. Why am I plussing? Because it is multiplication. So therefore I'm saying 1 plus 1 plus 1 is equals to 3. And then here I'm going to say B to the power of 2 and then C. And there's your answer. Alright, let's continue to 2.2. 2.2 now has the question of, I think I should just get a page here for myself so that I can just work a little bit quicker. So 2.2 has the question that's looking like 2x to the power of 3 multiplied with negative 3x to the power of 5. Alright, now we're going to say, please don't get confused here. It's 2, the coefficient multiplied with this other, so it's 2 here multiplied with negative 3. A positive multiplied with a negative is equals to a negative, so it's negative 6. X to the power of 3. Because my bases of x are the same, I can add. Why can I add? Because I'm doing multiplication here. Alright, so that's going to be 8. No? I'm skipping a step. I'm going a little bit faster because I know you're truly intelligent, but I know where you are understanding where that comes from. Okay? If I'm going too fast, please just remind me. No? What you can do, I told the learners in the previous class now. Sometimes you need to understand all of us are not on the same speed. No? And the reason also why I also learn still. I'm still a learner. So I learned from watching YouTube videos, no? And last night, before I went to bed, I watched something that I learned, and I watched. It was a 20-minute video, and you will see the longer the video, sometimes the greater the lesson there is that lies within. But it didn't have 20 minutes because I have a very strict schedule. I need to go sleep at a certain time. So what I did, I set the speed at 2 times. So that means a 20-minute video I watched in 10 minutes. Now I can only do that because I've taught my brain how to learn at that speed, and how when I watch at that speed it actually sounds normal to me. Alright? But what you can also do, if I'm going too fast for you, you can actually slow down because there's a slow down option for you as well. No? It's the slow down. Alright, we're going to use the slow down option currently. Let's try that. So at number 2.3. Alright, so at number 2.3, we're going to say 2.3 is equal, we have there 2a to the power of 4 multiplied with 4 to the power of 2. What I'm going to do, I'm going to take this 2 and this 4, I'm going to multiply it. So I'm going to write it out so that everyone can see. 2 times 4 is 8, alright? And then a, remember guys and girls, we're trying to accommodate everyone here. So here we have to the power of 4, to the power of 4, and then here we have to the power of 2. And then all I have to do is I need to go simplify this. 2 times 4 is equals to 8, 8 to the power of 6. There's your answer. 2.4. Guys, please, if I make a mistake, just raise your hand, no, so that I can correct my mistake. It's I'm also human, so please, I can make mistakes. If I'm going too fast, too slow, just raise your hand. So here we have 2.4. We have there a to the power of negative 4 multiply by a to the power of 7. Alright, just note here, coefficients of this is actually 1. So it's 1 times 1. I don't have to write that down or work it out. So I'm going straight to my variable. My variable is a in the first one and also the a. So now I'm going to say a to the power of negative 4 plus 7. And that I know a to the power of 3. Please write it nice. I saw a learner yesterday. I'm not going to say the learner's name or disclose anything about the learner, but I just went through the learner's book and I saw, and I don't want you to do the same mistake, but I saw that the 3 and the a is the same size. Now mathematically that's wrong, because mathematically what is standing there is a3. No? Now a3 is the same as 3a, which is not a to the power of 3. So there should be a clear distinguishing, where you distinguish between this and this. We call this subscript. Alright? And I remember last term, many of you, I couldn't even read out your names because of letters that you're not writing clearly. So please take note of that. We're going on now to number 2.5. All right. 2.5 there we have I hear a lot of conversation that I do not appreciate currently in this class, especially there at the back learners. Please, I need your participation here. I'm not doing this work for myself. It's for you at the end of the day. All right. So please bear also rule number 4. Especially the second part of rule number 4. Here we have x to the power of 3. I'm going to do that one. So it's 2 times with 3, which equals to x to the power of 6. Here's x to the power of 0. That we know is 1. No? So I'm just going to put in the 1 there, and then we have the x to the power of negative 2. Now the bases are the same. We can now write x to the power of 3 plus 6 minus 2. So that is going to be x to the power of 3 plus 6 is 9 minus 2. What is 9 minus 2? 7. So your answer is x to the power of 7. Right, moving on there, we have now question number 2.6. 2.6 looks like this, where we have 6a to the power of 5 multiplied with a divided by 3a to the power of 2. Alright, I'm first going to do the first two, so that's going to be 6a to the power of 5 plus 1, which equals to 6, and then I'm going to divide by 3a to the power of 2. So I can also write this, you can leave it like that, or you can say 6 divided by 3 is equals to 2, and then a to the power of 6 minus 2. Alright, so that's 2a to the power of 4. Then we have here 2.7. 2.7 looks like we have there 5x to the power of 3, y to the power of 5 multiplied with 3x. Is that negative 2? Negative 2, y to the power of 2. Alright. So 5 times 3 is equals to 15, x to the power of 3 plus, but that's going to become a minus, no? Minus 2, and then y to the power of 5 plus 2. So now I simplify the exponent, so that's going to be 15x to the power of 1, and then y to the power of 7. Do it again. Okay. Can I just do the explanation? No? So I'm saying 5 is the coefficient here. 5 times 3 equals to 15. Alright. Now in essence I'm saying x here is the same, that base and that base is the same. So we have x to the power of 3 and x to the power of negative 2. But what is between them is a multiplication sign. And I know if there's a multiplication, I should add my exponents. So in essence, this is now x to the power of 3 plus negative 2. So it's a plus times the minus, which equals to a minus. So 3, I subtract 2, I have 1 left. No? So that's why here is actually x to the power of 1. Are you with me? Here's actually x to the power of 1, but I don't write down that 1. Following? No? Then I have here, here's y to the power of 5. And then what else is there? Y to the power of 2. What am I doing? Multiplication. I'm doing multiplication, and when I'm doing multiplication, I can do what the law says I can add my exponents. So I have here 5, and then I have here 2. So if I add them together, I get 7. Good. Moving on now to question number 2.8. There we have 8y to the power of 3 multiplied by 1 over 4 y to the power of 2. Alright, now I'm going to take the coefficients and I can multiply the coefficients. That's actually 8 over 1 multiplied with 1 over 4. Now if you can recall from term 1, we did some multiplication of fractions, and I see a few learners was quite good with multiplication and division of fraction, or even addition and subtraction. No? Follow my eyes but don't look now. So what you can do before you even multiply out, you can say, okay, but 4 goes into itself once, it goes into there twice. So it's actually 2 over 1. And 2 over 1 answer is 2. So 2y to the power of 3 plus 2 is equals to 2y to the power of 5. Okay. Alright. 8. No? Everyone sees that 8? Alright. Let's quickly look at it at a different way. No? Because maybe that's going. What am I asking? I'm asking, what does multiplication mean? Because before you learn multiplication, you were taught, what was it in primary school? You were taught they sometimes ask you, what is a half of an apple? No? A half of an apple. So, but now the question is, if you have 8 apples, check here, 8 apples. So 8 apples looks like this. That's how many apples? 4. No? Let's put in another one there. How many have? 1, 2, 3, 4, 5, 6. Alright, that's not even, but imagine it's evenly split. 1, 2, 3, 4, 5, 6, 7. Put in another one there. Yeah. Okay. Now the question is 8. No? And what is a quarter of 8? What is a quarter of 8? Just check it in. I'm first going to start not with a quarter. I'm going to ask with a half. What is a half of 8? If I go into the middle, so that means a half times 8 times a half is equals to 4. Alright? But what is a quarter? So that is a halfway. But what is a quarter? A quarter is a half of a half. So you see, there's the half. So another half of that. So it correlates. So it's actually that too. Alright? But now I'm going to do it formally here. So I'm going to take that number. So I'm saying 8. No? And 8 is a, what did we say first term? 8 is a natural number. No? Do you remember those numbers? If you don't remember those numbers, go to the YouTube. There's a video there, which I did when I started here 300 years ago. I was teaching here grade 9. There's a video. No? You can go check that video, and that video has a good explanation on the different types of numbers and what you can do with the different types of numbers. But what I'm trying to say to you, the older videos are still relevant. Yes, the video of 300 years is still relevant to you guys, because that's the thing about maths. It looks different, but it actually doesn't change. No? So you can go check. It's not truly 300 years ago, but it's a while back when I was teaching grade 9, or when I started teaching grade 9, I did make some videos. The quality of that videos is not as good as the videos are currently, because that time we had a big camera. No? All right. So I had that big camera, and the learners, I could actually just accommodate 20 learners in my class because the camera was so big, it took up half of the space. But yeah, you can go watch that video on the different types of numbers. It is on my YouTube channel. Just scroll through there. And if you go through it, I'll try to add a link to that specific video underneath the comment section here below, so you can just view there. If you go and watch that video, please leave a like on that video and share a comment saying that you are actually watching the video in 2024, while that video was actually posted in 2018. All right? You see my 300 years now? All right. My maths doesn't work there. All right, but let's go. Getting back to this. 8 is a integer, no? But all integers can also be written as fractions. But what do we do to write this as a fraction? We write it over 1. All right? Now I'm saying 8 times the quarter. 8 times with a quarter. So I'm saying times with 1 over 4. Now I'm not going to do it on this way. I'm just going to do it on the other way. Without here, I did simplification. And I started yesterday, or when I started with exponents, I told you, why do we have laws? Who can remember why do we have laws? Why do we have laws? To know the method, okay. Why do we have laws? You don't have laws. Yo, guys. Why do you have laws at school? Why do we have laws in the country? Alright. If you know the question to this answer, write it down in the comment section below. I'm not going to give you the answers away. But what we are saying here, listen quickly. I'm saying 8 times 1 is 8. 1 times 4. Alright. How many times does 8 go into 4? Four goes in itself once, it goes into there twice. So the answer is 2 over 1, which equals to 2. Do you see? Many ways to skin the cat. Right, learners, the periods are exchanging. I want you to look at a few of the numbers. Try and do it quickly on their own. I'm quickly going to take an ad break. No? While you wait, I will be standing outside. So if there's any inquiries about your teacher, all you need to say, your teacher was outstanding. Ah, jene. Welcome back, viewers. So we're continuing with the exponents lesson 2, and we are doing trying to apply all of the laws that are applicable. Now, my question that I posed before the ad break was to the class, but also for you as the viewers at home. Why do we have laws? And if you know the answer to that question, please write it in the comment section below. We are continuing with question number 2.9. So 2.9 we have there a to the power of 3, b to the power of 2 and c. Dividing them by a, b to the power of 2 and c to the power of 3. All right. Please, if you can, I would make just to make in pencil so that I can remember, because sometimes we tend to forget that there's actually the invisible exponent there. Now we have here our bases being the same, and what kind of operation are we doing? A fraction is division. So I can now say a to the power of 3 minus 1, b to the power of 2 minus 2, and c to the power of 1 minus 3. Then I go work this out and I go simplify. There I have a to the power of 2, b to the power of 0, and c to the power of negative 2. All right. I'm just going to do this without the laws afterwards. I'm going to simplify my answer. So that's a to the power of 2 times the 1. And then the c. How can I leave I write it with a positive exponent. So this c, if I gave you c to the power of negative 2, that I would have written as 1 over c to the power of 2. So I can actually now just make sure that that c is written underneath here. I'm quickly going to do the same one. What happened to the b? The b is to the power of 0, and anything to the power of 0 is equals to 1. All right, so we don't have to write down that b, because no, anything multiplied with 1 just says the same. I'm going to do this now. I'm going to try and do it without using the laws. All right, so that you can just see if we get to the same answer. The laws in essence, and this is not the complete answer that I'm looking for in the comment section down below, but the laws in mathematics that we have, but I'm referring to all general laws that we have. That is the question. Why do we have the laws? No? The laws in mathematics is supposed to save us time. So if we look at that, a to the power of 3, what does that mean? What does it mean? 3 times a? No. It means a multiplied with himself 3 times. B to the power of 2 multiplied with himself twice. And then C, all right? Then I can now say there's 1 there. How many B's are here? 2. All right, now I'm going to do simple division. Now I'm going to do simple division. Smile for the camera. Now I'm going to do simple division simply by cancelling out. And here's the magic now. Look here, everyone, pay attention. The A cancels with that A. This B cancels with that B. This B cancels with that B. That C cancels with this one. Do you see what we have left? Hmm? But you don't have. The one is actually there, invisible. 1 times that A to the power. Alright, so he was asking where is the 1? Because this is b to the power of 0. No? So the 1 is actually invisible there in front because the coefficient is 1. Um, that's why we don't have to write it down. You can go. Alright? Listen up to me, guys, girls. Now, ladies and gentlemen, you can, and there's nothing preventing you from doing this on the long way. But the problem, however, becomes when the numbers of the exponents in increases. Then what is going to happen? Say, for example, if this is 30, are you going to write down a 30 times? Do you see why we use the laws? No? Because we can't, this is going to take too much time to do it overnight. So I'm going to pause there. I have given you a page. I know some of you are already done with everything. So I'm going to now allow you to try and do it on your own. For today in class, I want you to finish up until number 2.18. Is that fair? No? That's in class. And then for homework, you try and do number 3. You don't have to start with a page. However, if you are done, you can attempt the page on your own. Alright? But then the page is actually for Monday. No? So please remember all pages that I hand out should be pasted in your book, and this becomes a revision for you. It's Mr. Le Cordeur over and out. Yes. 2.9? Alright. Do you see that this answer is actually the same as this? Do you see that? Because here, what is left here? If I write down what is left here, there's 2 a's, so that's a square, and here I have c square. But I'm going to do it with the laws now. So here we have a to the power of 3, no? And here underneath we have a to the power of 1. So those two are the same. And once they are the same, and I'm doing division, what can I do with my exponents? Minus, yes. So I'm going to say 3 there minus 1 is equals to 2. You following? Smile there for the camera. All right, thank you. Are you following? Guys, one of your learners, rule number 4,